Hello everyone, welcome back to my channel. My name is Mohit and in this video we will study Singular Value Decomposition, also known as SVD. So SVD we have used several times in machine learning, in recommendation task in PCA, but most often we don't know what it actually does. So we know that we have a matrix A which is decomposed into three matrices U, sigma and V transpose. But why it is decomposed like this and what it means and what is the meaning of each and every these matrices. So in order to understand it, we will use a graphical method. So let's say we have a circle, okay, and now we want to apply some operation A. Okay, so A is a matrix which can be applied to any vector, right? Now, instead of applying A directly to any particular vector, we will apply these decomposed transformations to X one by one. Now, before going to see how this unit circle will be transformed, first let us analyze what is U, sigma and V. So, U and V are both rotational matrices and sigma is a translation matrix. Okay. So, if we apply this apply operation on this particular unit circle, so let's say it will first pass through this V matrix. So after applying this transformation, it will rotate these axes. So it should be like this. It will rotate it with some angle. So this will be your new x and new y, and your circle will remain intact. Okay. Now after applying this V transformation, we will apply sigma transformation. So sigma transformation will tell you how much you want to expand or shrink your object. So let us say I want to expand it 3 times along x-axis and 1 time along y-axis. So it should look like this. Okay. Now it has become an ellipse after applying the sigma transformation. And now let's say we want to not we don't want to align this ellipse along x-axis. We want to move it to some other angle. Then we need to apply a rotation transformation. So we will apply u, then it will be like this. Your ellipse will be rotated to some other angle. This is x, this is y. So all of these operations are being done by matrices A. Okay. So now let us understand it with some example. So let us say we have a matrix A which is given to us, which applies some operations 3 1 1 3. Okay, it could be any matrix, and we have a vector which is x. It is pointing along x-axis. So what SVD tell us is that when we are applying A on x, it simply means this thing U sigma V x. So first we will apply on x and then sigma then U. Okay. So now let us compute each and every step. So for this particular A matrix, we can find uniquely these three matrices U, sigma and V. So it is very easy to find. You can use Python or some other language. So basically your V matrix will be given by this thing 0.71 minus 0.71. Okay, and since we require V transpose, so it should be like this. Okay. Now we have to apply V transpose on X. So it means we have to apply on X, which is 1 0. So this will lead us to 0.71 minus 0.71. Okay. So now you can say this vector which is initially pointing towards x-axis is now rotated to some other angle. Okay. Now on top of that we need to apply this sigma operation. So for this particular A matrix, the sigma can be found out to be 4002. Now this we have to apply on this particular result. So it should be 4002 applying on 0.71 minus 0.71, right? So it is 2 by 2 matrix, it is 2 by 1 matrix, so it will give us 2 by 1 matrix. So it which give us the answer 2.84 and minus 1.42. You can also calculate it yourself. It's very straightforward. So you can see now this particular vector is stretched, okay, with the same along the same direction. So this is the step in which our unit circle became ellipse in the previous example. Now after applying sigma operation, we will apply U operation. So for this particular A matrix, U will be 0.71 minus 0.71, this and this. Okay. So now we have to apply U on 2.84 and minus 1.42. So when you will apply this uh, U matrices on this particular vector, you will get 3 1, which is exactly the same that we have obtained by applying the A matrices on X. Okay. So basically what SVD does, it does three things. So in the first step it rotates, and then it will stretch, and in the last step it will rotate again. So if you apply the matrix to, let's say, every vector in a circle which we have considered in our first example, so we have lots of vectors. Okay, so the circle will become an ellipse. Okay, so we have to apply these particular operations to each and every vectors of that particular circle. Okay, so basically what we will do, it will find the input directions, sigma will stretch it, and you will rotate the final orientation. Okay, so that's it about SVD. I hope you like this video. Thanks for watching.